All right. We're going to start out talking today about the rectangular coordinate system with a little bit of review of the coordinate plane, and then moving into graphics of different types of functions, and then we're going to go on to a little bit of application. So here we go. First of all, we're going to start out with the coordinate plane. The coordinate plane sort of looks like this. It's a cross of two lines that kind of give us this whole four coordinates, four quadrants sort of a thing. So looking at what we're labeling things here, this is the y-axis, as you probably know, and so that makes this the x-axis. Together they are the axes. And when we go to think about quadrants, this is quadrant 1. And this is quadrant 2. And this is quadrant 3. And this is quadrant 4. Okay, notice we're going in a counterclockwise sort of a motion when we talk about the quadrants. That's going to be important as we start talking about reference angles and things like that. So, other notable pieces of the coordinate system. Here is the origin. And the origin is 0, 0. And so when we're looking at the actual coordinates that go into these quadrants, here we might find something like 1, 1. And we'll notice that it's positive and positive. Okay, so it's positive 1, positive 1. When we move over to the other side, we get a negative x and a positive y. So we might get something like negative 1, 1. Down in quadrant 3, we're going to be negative and negative. So we might have a negative 1, negative 1. And in quadrant 4, we're going to have a positive x and a negative y. So we might have something like 1, negative 1. Okay? Important to remember these things. This is all pre-algebra, algebra 1 stuff, but it's important to kind of go back and reflect on that as we begin to talk about reference angles and coordinates and different types of angles and things like that. Okay? So, we're going to go ahead on to graphing. We're going to graph this line. There's a couple of different ways to do this. I'm going to show you one way, but there are other ways to do this. We will recall that we have things called intercepts. And if we could find the intercepts, that's where it crosses the x-axis and the y-axis. Well, if we have 2x minus 3y is equal to 6, where it crosses the x-axis is y equals 0. So we're going to let y equals 0. And what this is going to do is it's going to give us 2 points with which to graph this line. We'll see how it works. So we have 2x minus 3 times 0 is equal to 6. Well, this goes away because that's 0. So we have 2x is equal to 6. And so if y equals 0, x is going to equal 3. So we have a point here, 3, 0. And if we graph that point, we're going to go 1, 2, 3, 0. So this is 3, 0. Okay? The second half of that, the other intercept, is we're going to say this is 2x minus 3y is equal to 6. We're going to let x equal 0. If we let x equal 0, we have 2 times 0 minus 3y is equal to 6. This goes away because it's 0. Minus 3y is equal to 6. Divide by negative 3. Divide by negative 3. We get y is equal to negative 2. So, y equals negative 2. X equals 0. And so we have 0, comma, negative 2 as our other point. We go over and graph. And what we can do then is use those 2 points to graph. We're going to graph our line. So we'll come up and we'll graph our line. Okay? We found 2 points using the intercept. So I let y equal 0 and solve for x, and let x equal 0 and solve for y. Okay? Now, that's a line. That's a review from Algebra 1. Also in Algebra 1, we did graph parabolas, but we're going to go through that once again. The general parabola equation is y equals a times x minus h plus k. And there should also be an exponent in here, because after all, we are talking about parabolas. And so our exponent goes right here as a squared. Okay? This is our general equation for a parabola. H and k have special representations. H comma k is the vertex of the graph. That's where it comes to its peak. That's where it starts to turn over. The coefficient a should actually be little a, so there's no confusion. Little a stretches or shrinks the graph. If a is less than 1, the graph is flatter than y equals x squared. If a is greater than 1, it's wider than y equals x squared. Okay? So make sure you get that equation down, because that's going to help us in our next part. Okay? Remember, if you need to pause or rewind, please feel free. We're going to talk about the human cannonball. The 1997 Washington County Fair in Oregon, David Smith Jr., also known as the Bullet, was shot from a cannon. He reached a height of 70 feet before landing in a net 160 feet from the cannon. Sketch the graph of his flight and find the equation for his flight. Key pieces that we know here, it's 70. 70 was the maximum height. That's huge for us, and 160 feet is going to help us also. What do we know? Here's what we do know. H comma k is going to be for us the vertex. That's going to be the vertex for us. Well, what are h and k? Well, really, we know that in a parabola, it's equal on both sides. So a parabola goes like that. And so we know that h comma k, the height is going to be 70, because that's as high as he got. But we also know that he traveled a total of 160 feet. He traveled a total of 160 feet. And if he did that, then this point right here must be 80 feet. So our x is going to be 80 where we reach our highest point. Okay, so this is h comma k. Now, if we put this into our parabola equation, what do we get? The landing point out this way is 160 comma 0. Okay, we know that that's 160 comma 0 because he traveled 160 feet and his height would have been 0 at that point because that's where he traveled to. So if we have that h comma k is 80, 70, then our equation for our parabola is going to be thus. Y equals a times x minus h, or 80, squared, plus 70. I just put in my h and k, exactly where I got them from my vertex. Okay? Now, I have too many unknowns in here. I have a y, I have an a, and an x. But knowing that an equation for a parabola really describes every point along that parabola, if we knew one of the points, couldn't we substitute y and x in to solve for a? Yes, we could. What we could do is we could say that we already know where he ended up. We know that he was at 160 comma 0. And so what we're going to do is we're going to put 0 in for y, and we're going to say that's equal to a times x. And when he was at 0, he was at 160 minus 80 squared plus 70. Now, we have one unknown. We only have a, which is all that we need to complete our equation. And so what we're going to do is we're going to say 0 equals a times 80 squared plus 70. Well, 80 squared is 6,400. So 6400A plus 70. And we're going to go ahead and say that when we do this, we're finding out exactly what we want. Because if this is 6400 times A, then what we can do is we can solve just like we would a regular algebra equation. So we're going to subtract 70. So we've got 70 is equal to 6400A, or negative 70. So we divide by 6400 on both sides. So A is going to be equal to negative 70 over 6400. How does this translate for us? Let's look here. If we're talking about our equation then, what does this give us? We're going to fill in everything right now. We've got y equals, because we're writing the general equation now. Y equals A, which we already know, now, to make this easier on myself, here's what I'm going to do. I'm going to go ahead and divide 10 out of the top and the bottom. Okay, so I've got negative 7 over 640. And now I'm going to do x minus h, which I know is my negative 80, squared, plus my k, which is 70. Now notice, this looks exactly like something that has a y and an x that we could graph. This is good. These are good things. And so when I'm looking to graph, what exactly am I doing? I've got my graph paper down here, and the graph is actually, I think, the easier part, because what I'm going to do is I'm going to count out my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to go 10 per. So that's 10 right there. And I'm going to go 10 per up here. 1, 2, 3, 4, 5, 6, 7. So this is 70. I marked out 70 because I knew that was going to be the maximum height that I reached. And so if I go here, 10, 20, 30, 40, 50, 60, 70, 80. I'm going to go up to 70. And look what happens. I know that if he shot out of this cannon, okay, what happens is this. He starts flying, he reaches his maximum point, and when he gets to his maximum point, he starts coming back down again. Okay? But we are assuming certain things for this problem. And part of the thing that we're assuming is that he's going to travel in a regular parabola. And when he travels in this regular parabola, we'll assume that he starts from 0. And we can assume that because if he travels in a regular parabola and he starts from a certain height with his cannon, then we know that he's going to come down to that same height. So here's our graph. Could we find other points on the graph? Yes, we could. We certainly could. Okay, so that's how that works. We formulated the equation. Now, we're going to move on to circles. Let's talk about circles for a minute. Circles, when you graph them in a calculator, which we will do, circles involve graphing things in two pieces because there's going to be a positive and a negative part, but we'll talk about that later. This is the general equation for a circle. General equation. Notice there's no allowance for the center, but the r is the radius, and this would be centered at the origin because there's no h and k, nothing telling us where the center is, no x's and no y's. Okay? So there's the general equation for a circle. How does this work? We're going to graph these circles. And we're going to remember that a circle equation is x squared plus y squared is equal to r squared. Well, what are we asking you to do here? We're saying, what's the radius of this? Well, r squared is equal to 16, so r would be equal to 4. So I'm going to center it at the origin and go 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And I'm just going to connect the dots like such to form a circle. You see how I did that? Okay, so this is the graph of our circle. Over here, r squared is equal to 1, so r is equal to 1. So I'm just going to draw my circle right around my origin here. That one was almost harder to draw. Okay? That's pretty much it. That's how we graph parabolas, circles, and lines. And we talked a little bit about the coordinate plane. We'll see you tomorrow.